Hello everyone. In this video we're going to be talking about expressing repeated decimals as fractions. So first, as a reminder, what is a repeated decimal? I'm going to write an example here. For example, if you say 0.333 and the decimals never stop, we can just say it's 0.333 and then we put a line over it. So that means it is actually a repeated decimal. Now, we're going to be expressing repeated decimals as fractions. So in other words, we're going to be converting repeated decimals like the 0.33 into fractions, okay? So in our first example, we have this number 0.44, so this is repeated, so it goes on forever. It's 4, like that. So actually, we're gonna use a methodology. We're gonna name this number, okay, x, okay, and then from here we can actually do some things to this, because now we do have an equal sign. So we're gonna be manipulating the equation so that we can find out the real fraction value of this decimal. Okay, so first, since this is an equation, the first thing we can do is getting rid of this 0 point. Okay, so we're gonna try to eliminate this part of the decimal so that it's a number larger than 1. So in other words, we're gonna be doing this. So we know for a fact if you multiply a decimal number that starts with 0 point something with 10, so like if I multiply right side and left side by 10, what I'm gonna get is this. So basically 10 times x is 10x, okay? And then 10 times this, for example, like if you would say 0.7 times 10, so you're gonna just cancel the zeros, you will get 7. Or let's say you move the point one time to the right, okay? So we have 10x from the right side, and from the left side, we're gonna be moving this point one time to the right, okay? So this is going to be a 4 point, okay? And then 4, 4, 4 forever, okay? So this step is a little bit tricky, but this is what we're gonna do, okay? So now 10x is equal to this 4.444 forever, okay? So from here, we can actually do other things to equations, such as subtracting the same number from both sides. For example, we can write this again. So 4.444, this is equal to 10x, okay? Now I can actually subtract x from the right side. And if I do that, I have to do the same for the left side, okay? So since we said x is actually originally equal to 0.444, we can replace this x by that number, okay? Because it's the same thing. That's how we named it, okay? So like that. Okay, so someone might be asking, why we subtract by x? Why not subtract by 2x or something like that? Well, since you started with a decimal, and actually all the decimals are ratios out of 10, out of 100, out of 1000, okay? So if you do the same thing, for example, you leave it like that, you will end up with the same thing. You won't get any fraction results. That's why we subtract 1 from it, okay? Now, 10x minus x, obviously you get 9x because you have 10 things, and then you subtract 1, you get 9x. And for this, even though you can do it visually, but if you don't, it's fine. You can use the vertical subtraction method. So we have this number, you can write it down like this. So 4, 4, 4, and forever. Okay, and then you write this number, so you subtract them. 0 point, but the only thing that you have to be careful of is this. The points should be above, or let's say below each other, so they have to be aligned like this, okay? Now 0.4444, okay? Now, this is just a simple subtraction, even though this continues forever. So we can see actually these two cancel, 4 minus 4, 4 minus 4, 4 minus 4. You get the whole idea, right? And then 4 minus 0 is 4.0, or just what? Or just 4. So this subtraction, this difference is actually just 4. Okay, cool. Now we end up with this situation. We actually recognize what to do from here. So if you have a number on the other side and then a number next to the variable, and this is all what you have, you always do this. You subtract both sides by the number next to x. Okay? So now 9 is going to cancel 9, so we're gonna be having x and then 4 over 9. So basically, if you divide 4 by 9, you will end up with the decimal that we started. Or equivalently, if you have this decimal, you can express it as 4 over 9. Now, for the second example, we're going to be doing the same thing. So we're going to be naming this x, okay? And then from here, what do we do? Well, actually, you might be thinking, oh, we're going to multiply by 10. Well, here you have to stop and think again, because this repeated decimal, even though it was repeating forever, so non-stop, but always it was a 4, 4, 4, 4. So basically the same digit. Okay, so basically 1 0 here. So we multiply by 10. So can you guess it now? We have two different digits that are repeating. So like 37, 37, 37, 37. But each 37 has two digits. So I think you guessed it. Yes, you're right. We're going to be multiplying both sides, not by 10, by 100. Okay, so let's see what happens. So the point is going to move 2 times. So it's going to be 37 point and then 37 forever, okay? And this becomes obviously 100x. Again, that's the only different step between these two. From there, it's just the same thing. Okay, so basically we're going to be subtracting x from both sides again. So 100x, okay? Again, the same thing from this step. So minus x minus x. And we said that x is equal to the thing that we named first. So instead of x here, we can just write 0.37. So 0.37 repeated, okay? All right, so obviously 100 minus 1 is just 99x. And then for this, you can do the same thing here. So basically, write them down. Okay, the first number 37.37, 37, 37 forever. And then, as I said before, be careful of this. So the points has to be exactly below or above each other, aligned. Okay, so you're gonna be writing this like this. So 0.373737 like that. Okay, so if you subtracting these, we're gonna always get 0. Okay, because like 3 minus 3 is 0, 7 minus 7 is 0, like that, 0, 0, 0. And then 37 minus 0 is 37 or just 37. Okay, if you do a lot of these, you will get used to it and you don't need to do the vertical subtraction, but it's fine. All right, so now we end up with the situation again. So always we do subtract by the number next to x, okay? And therefore, these two cancel each other out. So x is equal to 37 over 19.9. And that's how you actually convert repeated decimals to fractions.